typically I would work out practice problems with you guys. I would rather you ask me how to do the practice problems in class. But for this occasion, I noticed that these practice problems that I want to cover aren't very similar to the structure of the notes. So I want to cover this and walk you through each step. So these are more likely that problems that I would put on a quiz or a test, so I want to go through them step by step with you guys. So let's get started. So for question 1, what you're going to be given is a graph, and you're going to be asked to evaluate the f and g functions. As you can see, this one's f, this one's g, but you have to find the inverse value, and that's a little bit tricky. So first off, let me just go over the basics on how you can understand this. When you have an inverse function, or actually let's start from, square one. When you have a function, typically you have an x that's inside, and what comes out is your y, is when we typically think of a function. But when you have an inverse function, the x and y's are switched. So in this case, the inside really is your y value, and the outside spits out the x value. So if you can understand this format, then you can evaluate these functions. So when I see this, I have to switch my brains a little. I have to understand that this means inverse of f, and that this -4 is not the x value, it's the y value. And so again, this is the y value. So when you go to the graph, you actually have to find the x value. So you'll go to the f function, you'll go to -4 for the y, so that's going to be down here. And if you look at the graph, notice that the x value is going to be right here. So at -4, the x value is 2. So my answer is 2. Let's do this again for our g. So again, this here is your y value. You're going to go to g, and you have to go to the y value of -1. So you'll go down to -1 for y, and looking at your curve, that's going to hit it here at -2, it says. So at -1, the x value is -2. Now here's a caveat. Notice how the f function, it would pass the horizontal line test, which is good. But the thing is, g isn't so nice. It does not pass the horizontal line test, because if I were to draw a line right here, notice it would hit almost 5 spots that it would hit. So this does not pass the vertical line test. So this is not a inverse function. Okay? And so and it's because it does not pass the horizontal line test. So this value is actually not quite true, but if this were an inverse function, if it could be an inverse function, then it would be at -2. So I'm going to put a little asterisk here to show that this technically would be -2, but it's not an inverse function. So I'm going to put this is what it would be if g had an inverse. But it doesn't, because it failed that horizontal line test. So that's what I was getting at. But again, I just want you guys to practice finding inverse values, not so much whether you are checking if it's horizontal or not. So in this one here, there is a g inverse of, if you guys remember the composition notation, g of 3. So first, whenever you have graphs and you're evaluating these notations, I would change them into parentheses. So this as a parenthesis would be g first, inverse, g next with the 3 inside. So that's how I can change it into parentheses form. And so inside here is saying g of 3. This is just normal g of 3. So this is an x value. So you would go to x equals 3 and find the y value, which is, in this case, 4. So you have g inverse, but now you have a 4. So g of 3 was actually 4. Now you're going to find g inverse 4. So remember, this is your y value because this is an inverse. So if you go to g and you go to y equals 4, the x value there is 3. So at y equals 4, the x value is 3. And so that there is your final answer. All right, let's try another one. So again, this is going to be f first. So I'm going to change this as a parentheses form. Write in the 2 for, sorry, did that too fast. Write in the g and then put in the 2 inside the g. And so this is g of 2. So I'm going to do the inside first. G of 2, this is a normal g, not an inverse. So I'm going to go to x equals 2. Find the y value, which is 1. And now I have to find the inverse of f at 1. So again, this is the y value. So you want to go to the y value at 1, find the x value, which is also at, so at 1, it's negative 1. So for the next problem here, you have a inverse. Both of them are inverses. So let's rewrite this as a parentheses form. So you would have your f inverse outside and then your g inverse inside. And when you're working this out, I notice this is a inverse. So this is a y value that's inside. So that's negative 1 for y. So here's negative 1. Now there is no curve on this side, so it's on this side. So at negative 1, the x value here is negative 2. So let's replace that g to negative 2. So all of this got replaced with negative 2. And now when I look at this, this is f inverse. So this is a y value. At negative 2 is here for the y. And so that would be this point, and that x value there is 1. So this is 1. And that's it. All right, we're heading into question 2 here. Question 2 is asking you to find the composition function where you are actually plugging in numbers. So when you're plugging in numbers and you're given the two functions, I would probably start with actually rewriting this as a parentheses. I think that we're in that rhythm. Let's rewrite it as a parentheses. So f comes first, g is next, and then 4 is on the inside. So first off, I am going to start off with finding this here, g inverse. So if I were to do that, remember, this here is our y value. This g means that if this is our y value, that would mean I would have y, but I need to find the x. So what I'm going to do is set 4 equal, because in case you guys don't remember, anytime you see f of x or g of x, those are your y's. So I'm going to plug in this y value for here and set that equal to 2 square root of x. And notice I'm doing this to the side. So what I'm going to do is solve for x, and then whatever x is, I'm going to plug it back in for the inverse, because the inverse helps you find the x value. So I need to find this x value. So to solve this out, I'm going to have to divide by 2. That cancels. Square root of x, 2. 4 divided by 2 is 2. Get rid of a square root by squaring. And so this ends up being, x, and then 2 squared is 4. So that means that x equals 4. In other words, the inverse of g4 is 4. A little bit weird, but I guess that's the case. So let me rewrite that here. So the inverse of negative 1, 4, or g negative 1, 4 is 4. So I've replaced that with 4. Now I need to find the inverse of f at 4. So same thing. This is your y value. So you want to plug that in here and solve for x. So let's do that to the side. So this will be 4 equals 1/4 x plus 4. And we're going to solve for this x. So I have to move this 5 over. And so if I subtract 5, this would give me 1 equals negative 1/4 x. To get rid of a fraction, you can multiply both sides by its reciprocal. So in this case, I'm going to multiply 4 to each side. So that would cancel. X comes down. Negative 1 times 4 is negative 4. And so in this case, this here is my answer to that inverse. So this is going to be equals negative 4. That is my final answer. So that was a lot of steps. So essentially what I did was change them into a parentheses form and did the inside first. So I found the inverse of g by plugging that number in for y and solving for x. Once I found that number and replaced it, again, this is the inverse, so you're going to use this for the y value, solve for x, and there you have your actual value. So let's try this again here. So very similar process. You're going to change this to parentheses form. At least that's what I recommend. You don't have to do it this way. So you're going to start with the inside always. And so this is the inverse of f. So this 9 represents your y value. So you're going to plug this in for your y and solve for your x. So this is going to be 9 equals 1/4 x plus 5 and solve this out. So subtracting the 5. This would give you 4 equals 1/4 x. You would multiply both sides by 4 to get rid of the fraction. And so x equals 16. So this here, inverse of f, 9, is going to be 16. So this is g inverse 16. So again, this is an inverse, so that means 16, here's a y. You're going to plug that in for the y value for g. So 16 equals 2 square root of x. Notice how all this math here is being done to the side, and then I'm just replugging it in. This is probably the most organized ways to do it. So you're going to divide by 2 to get rid of that 2. And so this is 8 equals the square root of x. To get rid of a square root, you take a square. So that helps you cancel, but you have to square the other side. So x equals 8 squared is 64. So my answer here is 64. And that's it. All right, let's do one more of these that where you're plugging in a number. So again, this is going to be the inverse So this would mean that this is taking the inverse of f and then plugging in the inverse of f again, plug in 6. So let's start with finding just this part. So again, this is an inverse, so this 6 represents the y value. You're going to plug in the y here, solve out your x. So let's do that to the side. 6 equals 1/4 x plus 5. We're going to subtract 5 to both sides. That cancels. So this would be 1 equals 1/4. Multiply by 4 to get rid of that fraction. So x equals 4. So that means when I go back and replace just this part here, this is going to be 4 that goes in. Now I have to figure out what this is again. So I'm plugging in a 4 into the inverse of f. So this is your y value, and you're going to solve out for x. So this is going to be 4 equals 1/4 x plus 5. So again, you would subtract 5 to both sides. That would make a -1. And then 1/4 x drops down. So all I did was subtract, bring down. I'm going to multiply by 4 to get rid of this fraction. That would give me x equals -4. And so this here is my final answer. The inverse of f for 4 is -4. So for our next one here, D, it's a little bit more of a challenge because you can see it wants to find f of g. So if you remember f of g, f comes first, and we're going to plug in g is what it's asking. But then it wants you to find the inverse of this function. So I know this is a weird notation, but I want you to think about the thought process for a moment. We're going to have to figure out what f of g is here. So I'm going to do this to the side, and then it wants you to find the inverse. So we're going to find the function first, and then find the inverse. So to find f of g, do it to the side, we need to plug in our g, which is 2x. 2 square root of x, and then we're going to plug this guy in for our f. So there's only one place you're going to plug it into. It's that x next to the 1/4. So that's going to be, let me do this here, the 1/4, and then next to it will be 2 square root of x plus 5. And since this 2 is right next to the 1/4 when you multiply, 1/4 times 2 is going to be 2/4. Which ends up being, I think, 1/2. 1/2 square root of x plus 5. So let me scoot this over. In fact, let me just rewrite that here. 1 1/2 square root of x plus 5. And if you don't know how I got the 1/2, all I did was take 1/4 and multiply it by 2. So to the side here, 4 times 2, or 2 over 1. If you multiply straight across, you get 2 over 4, which is 1/2. And so that's how I got the 1/2 that's here. I just multiplied the fraction and the 2 together. And so here's my, my composition function, this guy here. But what it wants to do is take the inverse of this guy. So those are our 3 steps from the beginning video where you have to switch the x and y. So this here is your original equation. Think of this as y equals 1/2 square root of x plus 5, but you have to switch x and y. So let me do this in a different color. So this is x equals now 1/2 square root of y plus 5. Now that I have this part done, I'm going to actually solve for my y. So to do this, let me get rid of this extra piece here. Get this out of the way. There we go. So to work out this problem, I have to move the 5 over. So I'm going to subtract by 5. Again, I'm trying to get y by itself. So remove the thing that's furthest away. So x minus 5 equals 1/2 square root of x. To get rid of a half, I need to multiply by the reciprocal. In that case, it would be 2. So I multiply by 2 to get rid of that denominator. So I have to multiply 2 on this side. Now, when you multiply by 2, you have to give the x a 2 and a 5 a 2. So I'm going to wrap it around parentheses so I don't forget. Square root of y, 2x minus 10. And then to get rid of a square root, you have to take the square. And that would cancel out the root and the square. But I have to square this side too. So then this would be y equals 2x minus 10 squared. And I'm just going to leave my answer like this. But this here would be the inverse function. So this is the inverse of y. And I am done. Whew, that was a lot of steps. So first I had to figure out what the composition function was and work that out. And I got to here. But then it wanted the inverse because of this -1 is telling me the inverse. So I had to find the inverse by switching x and y, solve out for y. So once I got to here, I'm not going to actually FOIL this out. I could, but I'm just not going to, just because I like it like this, much cleaner. And so this here is the inverse of that original function. So there you go. So that's the end of this video. Hopefully that helps you understand the practice problems a little bit more clear. If you have any questions, guys, feel free to come to office hours. But that's it. Bye, guys.